Sorry that first video got interrupted, but like we said, we got number 1, which was 16. Now, the second one is a little different. The negative sign is actually, since there's no parentheses, this negative sign is out in front. So it is not technically connected with this 2. So this is a negative in front, and then 2 to the 4th. So all you do is take 2 to the 4th power, which is 16, but that negative sign stays in front. So your answer would actually be negative 16. So make sure you're careful with ones like that. You have to make sure you take, if it's not in parentheses, it's the number to the power and then with the negative sign left in front. Alright, next one. We have, in parentheses, negative 3 to the 3rd. So if I type that in, that will give me negative 27. The next one is not in parentheses, so therefore we take 3 to the 3rd power, whatever that is, we then leave the negative in front of it. So 3 to the 3rd power is 27, and then there's a negative still in front. There's actually a pattern to these if you pay attention to it. If they have an odd exponent, an odd number as your exponent, they'll both be negative. So anytime it doesn't matter what the exponent is. If it's odd, they're both negative. If it's even, that's when they'll alternate. But the main thing to remember is if it's in parentheses, you take the actual negative number to that power. If it's not in parentheses, that negative's out in front with the number then to the power from there. All right, let's look at these. It says evaluate each expression. So the first one we have 3 plus 2 times 3 to the 4th power. So actually this is should be very simple. It's just order of operations. So whenever you're doing order of operations, you start with your exponent, which here is 3 to the 4th. So I'm going to simplify that first. So I'll bring down my 3 plus 2 times, and then 3 to the 4th power would be 81. Then from here we have 3 plus 2 times 81. Multiplication should come next in order of operations. So 2 times 81 is 162. And then finally we have 3 plus 162, and that is 165. So there's your final answer when you evaluate each expression. Okay, let's look at the second one. We have 3 to the 2nd minus 8 to the 2nd divided by 2. So again, first thing you should simplify is your exponents. We have 2 sets of exponents here, so I'm going to do both in the same step. 3 to the 2nd is 9. 8 to the 2nd is 64. Bring down the minus between them and then divide by 2. So next we have subtraction and division. Remember, division comes before subtraction, so we do 64 divided by 2. 64 divided by 2 should give you 32. And bring down the 9 minus. Okay, finally 9 minus 32 should give you negative 23. So that should be your final answer for that one. Evaluating the expressions should be simple. You should know how to do order of operations, so just keeping your work organized should work for that one. All right, now we get into the next thing. These are 3 properties of exponents. So first, we have product of powers property. These all have similar names, so it's hard to, so just pay attention to each one. Product of powers property is to multiply powers with the same base, so you're looking at the same base, you add their exponents. For example, if you have 4 to the 2nd times 4 to the 3rd, your answer would be 4 to the 5th. Because all you do, if these have the same base, they both have a base of 4, you do 2 plus 3, and that gives you 5. So 4 to the 5th is the answer for that one. Next, power of a power property. To find a power of a power, meaning you have, and you'll see it in the example, you multiply the exponents. So here, there's only one base. 4 is your only base. It's taken to the 6th power, but then that whole thing is taken to the 3rd power. So if that's the case where you only have one base and it's raised to 2 different powers, you multiply the exponents, and that becomes 4 to the 18th. So if you have two bases that are the same, you add the exponents. If you have one base raised to 2 powers, you multiply the exponents. And then finally, to find the power of a product, find the power of each factor and multiply. So what that means is, if you have, in parentheses, multiple things being multiplied together, so 3 times 2, and that whole thing's taken to the 5th power, it's pretty much like distributive property. You're taking that 5th power to the 3 and the 2, everything inside. So that becomes 3 to the 5th times 2 to the 5th. You'll see examples with exponents like that, or with variables like that. So understand, if you have things on the inside of parentheses being multiplied, you take that power on the outside to each one. So I know those are all kind of similar. So let's look at some examples first of the first one. Simplify the expression, write your answer as a power. Okay, so first one, we have 2 to the 4th times 2 to the 5th. First of all, we have the same bases. So if we have the same base of 2, we keep the base and we add exponents. So 4 plus 5 is 9. The actual math of it's very simple. It's just remembering not to multiply them if you have the same base. So same thing here. We have the base of x. So since we have the same base, we add the exponents again. So x to the 10th. Okay, you can try these last two. Here we have 6 as the base on both. 6 to the 2nd times 6 to the 7th. So 6 is our common base. So we bring that down. 2 plus 7 is 9. And then lastly, we have a as a common base. So we add the 8 and the 5 to give us 13. Main thing to remember is just whenever you have common bases that are being multiplied, you add their exponents. Add the exponents. Also, I'll have people get that confused or get that mixed up. So make sure you remember, same base, add your exponent. Alright, next one. Simplify these expressions and write your answer as a power. So now we just have one base. So since we just have the one base, but it's raised to 2 powers, that's where we have to multiply our exponents. So 3 to the 4th and then that to the 3rd, we still have the same base of 3, but now we're multiplying our exponents of 4 and 3 to give us 12. So 3 to the 12th would be our answer. Next, we have w to the 5th and all of that to the 4th. So the one base of w comes over, and then we multiply exponents 5 and 4 to give us 20. Now you can try these last two. Here we have the base of 5, and it's raised to 2 different powers, so I am going to multiply those exponents. So 2 and 3 multiplied together gives me 6, so 5 to the 6th power. And then lastly, we have y to the 4th to the 6th, so we have to multiply 4 and 6 to give us 24. So again, 2 bases, I add the exponents. 1 base, I multiply the exponents. So hopefully you can remember to keep those separated and understand which is which. Okay, so let's look at that last type, which is to simplify these expressions. So here we have 2x on the inside to the 3rd. So remember, if you have things being multiplied on the inside of parentheses and all of it's raised to a power, you're pretty much distributing that exponent through. So here, 2 and x are being multiplied, so what I'm going to do is distribute that 3 to both of them. So that becomes 2 to the 3rd times x to the 3rd. Let me make sure they want us to take it all the way to being simplified as far as it can be. Because if they do, yes, they do. Okay, so once you distribute, if it wants you to simplify, you have to simplify completely. So here, 2 to the third, we actually can figure out what 2 to the third is. Because remember, 2 to the third just stands for 2 times 2 times 2. So that would be 8, and then x to the third we can't do anything with, so we bring it over. X to the third. So there's our final answer when we simplify. 8x to the third. So all you're doing is taking that exponent on the outside and distributing it to each on the inside. Okay, let's look at the next one. 3xy to the second. So there are 3 things on the inside, so now we're going to have to distribute this power of 2 3 times. So that gives us 3 to the second, x to the second, y to the second. And then finally, if I have a base that's a number, I can simplify that. So 3 to the second is 9, and I bring over my x to the second, y to the second. So there's my final answer for that. Okay, you can try these last 2. So here, we have ab to the 5th. So I'm going to take that 5th power to both of those. So we have a to the 5th, b to the 5th. We have no number to a power or to an exponent, so therefore that would be my final answer. I can't simplify that any further. Last one, 0.5 mn all to the second. So I take that to each part. First, I have 0.5 to the second, m to the second, and n to the second. Here I do have 0.5 to the second, so I can simplify that, and that is 0.25, and then I bring down m to the second, n to the second. So there's my final answer. So, a lot of different properties that we talked about with exponents in this lesson, but those are things you need to keep straight because then they'll be used later on for more complicated problems. So understanding the base of it is important to then use later on. Thanks.